All right, welcome back to this experiment where we're gonna read all the public educational materials for the Nvidia certification. Now, the one I'm choosing is Nvidia in the data center, AI in the data center, because I believe this is going to be a multi-trillion-dollar space in the by the year 2030. So I think now is the time where you can position yourself to be valuable in that space. If you wait and all the news headlines are like, oh, $1 billion this, $1 billion that, you're too late. You want to be the person that during the hiring rush of desperately trying to get people to work in these data centers, you've been there for a number of years already. You're going to be the senior person there trying to desperately hire a bunch of new people to help with stuff. So now's the best time to be doing that. So I'm going to go for the AI in the data center cert. I've got a handful of certs that I think would really help my career, and they're all associate level or lower certs. JNCI ESP, a high level mega cert. I just don't believe in it. My goal is to keep working remote from home. So you're just kind of at the mercy of whoever needs a JNCIE. It's just too specialized for me. So I want to become more of a generalist. I want to be really solid in AI, in cloud, and in my trad networking stuff as well. I held the CCNP Enterprise for a long time. I think I renewed it at least once. And I've had the CCNA for about 10 years, valid unexpired CCNA for about 10 years. So, and then Python. I've been using Python all throughout my career. So that's really where my niche is right now. So it's a great niche to be able to pivot into being valuable in this multi-trillion-dollar data center space. But I can't just stay where I'm at. I can't just double down on my skill set. I have to shift to learning more about cloud and to learning more about AI, and specifically to be associated with Nvidia, because Nvidia is going to be the company that's leading the way. All right, so let's see where I left off. I left off in here. We're going to learn about the Nvidia RTX, which is kind of cool because the RTX, as far as I know, is the consumer accessible one. So it's the one you might have in your computer if you have a gaming PC. I have one in mine. Yeah, this will be exciting to learn about because it's only about $300 or so to get in like a decent RTX. So you can definitely do things with this. All right, and I'll do my strategy where I put on the timer. It says it should take 3 minutes. It'll probably take longer than that, but the goal is I don't want to spend 3 hours on something that was supposed to take 3 minutes. So if it's 6 minutes, even 12 minutes, then that's fine. I just want to have a sense of how long it takes me. All right, so no time wasted. So the Nvidia RTX A6000 graphics card, performance amplified. Unlock the next generation of revolutionary designs, scientific breakthroughs, and sound checks. and sorry, I had to do a sound check. And immersive entertainment with the Nvidia RTX A6000, the world's most powerful visual computing GPU for desktop workstations. With cutting-edge performance and features, the RTX A6000 lets you work at the speed of inspiration to tackle the urgent needs of today and meet the rapidly evolving compute-intensive tasks of tomorrow. So specifications, we have the data sheet here, but we have a summary as well in this table. So we have GPU features, and we have as they apply to the Nvidia RTX 6000. So GPU memory, we've got a lot of GPU memory, 48. Yeah, so well, I think that this is one of the key ones, right? Is like, how do you plug a screen into it, right? Well, you have to use display. These are the ports you get. These DisplayPort 1.4 A. Yeah, so you're going to use these DisplayPort cables, and you have to plug it into like, either an adapter or into a screen that has. So let's do like a split. Let's type in monitor. So yeah, now we have um let's go to shopping. So here we have some monitors, gaming monitor that probably has these display ports. Let's take a look at this. So it's pretty cheap, only okay, there we go. So now let's try to see if it has a display port, if there's some specifications or anything. Highlights, not in the highlights. So it appears to not tell you what kind of port it has, which is kind of a problem. All right, so well, that's too bad. Yep, and now they want me to take a survey. So problems galore. Anyway, here's the shopping. So yeah, here's an A6000. There's also older ones. The 5000, the 4000. So you might be able to honestly like make a dent in doing something impactful. There's people who have made video games like what's like there's a classic, like Undertale, like working on a potato, right? So like relative to what the latest AI is, you can do a lot on like a potato. That's an expensive potato, but a potato nonetheless. So it's just kind of exciting to know that. But anyways, let's not get distracted. We're already ran out of the time it was supposed to take. Okay, max power consumption 300 watts, graphics bus, PCI Express Gen 4 by 16. Form factor, supporting, so if it fits on your motherboard or not. Thermal, this is interesting. So it depends on your motherboard, right? You have to have a motherboard that supports this. NV, but we can see, it's just a PCI Express Gen 4 by 6 slots. So like most motherboards will be able to put that. But then it depends on the bus of your motherboard too, whether or not you get the full features of it. So yeah. Don't need to read all of that. Now, this is what's cool. And I apologize. I'm getting a little bit nauseous. So I'll pause it. I'll be right back. All right, I'm back. Sometimes speaking is hard. So it should be better now. So exceptional performance by design. And I can restart this timer. All right. So NVIDIA Ampere architecture-based CUDA cores, double speed processing for single precision floating point, FP32 operations, and improved power efficiency provide significant performance improvements for graphic simulation workflows such as complex 3D aided design CAD and computer-aided engineering (CAE) on the desktop. 48 gigabytes of CPU memory. Ultra-fast GDDR6 memory, scalable up to 96 gigabytes with NVLink, gives data scientists, engineers, and creative professionals the large memory necessary to work with massive data sets and workloads like data science and simulation. And then we've got second generation RT cores with up to 2 times the throughput over the previous generation and the ability to concurrently run ray tracing with either shading or denoising capabilities. Second generation RT cores deliver massive speedups for workloads like photorealistic rendering of movie content. Architectural design evaluations and virtual prototyping of product designs. This technology also speeds up the rendering of ray-traced motion blur for faster results with greater visual accuracy. Then we've got virtualization ready, support for Nvidia virtual GPU vGPU software allows a personal workstation to be repurposed into multiple high-performance virtual workstation instances, enabling remote users to share resources to drive high-end design, AI, and compute workloads. So there you go. You can set this up and actually like hire remote users from all around the world to help you develop some product. PCI Express Gen 4, support for PCI Express Gen 4 provides double the bandwidth of PCIe Gen 3, improving data transfer speeds from CPU memory for data-intensive tasks like AI and data science. Third generation tensor cores. New TensorFloat 32 TF32 precision provides up to 5 times the training throughput over the previous generation to accelerate AI and data science model training without requiring any code changes. Hardware support for architectural sparsity doubles the throughput for inferencing. Tensor cores also bring AI to graphics with capabilities like DLSS, AI denoising, and enhanced editing for select applications. Then we have power efficiency, featuring a dual slot power efficient design. The RTX A6000 is up to 2 times more power efficient than Turing GPUs and grafted to fit into a wide range of workstations from worldwide OEM vendors. And I think I forget what OEM stands for. I think it's original equipment manufacturer. Yeah, there we go. So let me see how much these cost. Yeah, so not bad. Not bad comparatively, right? I mean, it's kind of a similar. Yeah, workstation card. This is a workstation card. Yeah. Oh, it doesn't come with a cable. See, there's a lot of people who like know what's going on with this. And they're making jokes, right? Okay, so then the last one is third generation Nvidia NVLink, increased GPU to GPU interconnect bandwidth, provides a single scalable memory to accelerate graphics and compute workloads and tackle larger data sets. So if we want to take a deeper dive into Nvidia RTX, we can read that, but we're already well over the time. So yeah, not at all. I do want to briefly look at see how. So see, you can make digital art with it. You can give people like virtual experiences. It looks like with it. You can like design cars. You can make it's a yeah. I feel like there is some more. So design showcase RTX the stars. They're using powerful features to elevate graphics workflows. Providing captivating work that has pushed them to the level of NVIDIA RTX All-Stars. Then we have multi-GPU scalability, NVIDIA NVLink Bridge. NVLink enables professional applications to easily scale memory and performance with multi-GPU configurations with a low-level design that fits into a variety of systems. NVIDIA NVLink bridges allow you to connect two RTX A600s. This delivers up to 12 gigabytes per second of bandwidth and a combined 96 gigabyte GDDR6 memory to tackle the most memory-intensive workloads. So I'm not sure what this is all about. It sounds like it sounds like it's some piece of hardware. All right. Anyways, good news. Look, we're done with the GPU section. So next is the infrastructure section. So we got a 2-minute reading here. Let's look at that. So we're gonna set the timer to 2 minutes. Pull it up. All right, and now we're on to infrastructure. So this is yep. So let's do that. So we're gonna do a okay. So 2-minute timer. And we'll read this through. MPI solutions for GPUs. MPI message passing interface is a standardized and portable API for communicating data via messages, both point-to-point and collective, between distributed processes. MPI is frequently used in HPC to build applications that can scale on multi-node computer clusters. In most MPI implementations, library routines are directly callable from C, C++, and Fortran, as well as other languages able to interface with such libraries. MPI is fully capable with CUDA, CUDA, Fortran, and OpenACC, all of which are designed for parallel computing on a single computer or node. There are a number of reasons for wanting to combine the complementary parallel programming approaches of MPI and CUDA slash CUDA Fortran slash OpenACC to solve problems with a data size too large to fit into the memory of a single GPU, to solve problems that would require unreasonably long compute time on a single node, to accelerate an existing MPI application with GPUs, to enable a single node multi-GPU application to scale across multiple nodes. Regular MPI implementations pass pointers to host memory, staging GPU buffers through host memory using CUDA memcopy. With CUDA-aware MPI, the MPI library can send and receive GPU buffers directly without having to first stage them in host memory. Implementation of CUDA-aware MPI was simplified by Unified Virtual Addressing (UVA) in CUDA 4.0, which enables didn't hit it in time for the timer. That's okay. Which enables a single address space for all CPU and GPU memory. CUDA-aware implementations of MPI have several advantages. CUDA-aware MPI is relatively easy to use. Applications run more efficiently with CUDA-aware MPI. Operations that carry out the message transfers can be pipelined. CUDA-aware MPI takes advantage of best GPU direct technology available. With Kepler class and later GPUs and HyperQ, multiple MPI processes can share the CPU. Implementations of CUDA-aware MPI are available from multiple sources. So the first source they're available from is MVA PICH 2. It's an open source implementation of Message Passing Interface, MPI, and simplifies the task of porting MPI applications to run on clusters with Nvidia GPUs by supporting standard MPI calls from the GPU device memory. The next is IBM Spectrum MPI. It's a high-performance production quality implementation of MPI designed to accelerate application performance in distributed computing environments. Then the next is the Open MPI project. It's an open source MPI-2 implementation that is developed and maintained by a consortium of academic research and industry partners. GPUs are supported by version 1.7 and later. There we go. So that's it. Didn't go too far over for that one, so that's good. All right, next we got a big one, 7 minutes. Which for me will be 7 hours. All right, so there's multiple videos, and it looks like there's more than one article. There's multiple articles on here as well, so I'm not sure which article exactly to read. So it looks like this one has a reading time of 8 minutes, so this is it. All right, so what is ML Ops? Machine learning operations, ML Ops, are best practices for businesses to run AI successfully with help from an expanding smorgasbord of software products and cloud services. So this is one of those ding, 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 Pee Wee Herman word of the day. Everyone scream, ML Ops isn't going anywhere. And by that, I mean it's here to stay. As this becomes a multi-trillion-dollar industry, there's going to be ML Ops teams, believe me. All right, so the ML Ops, the AI lifecycle for AI production. So we've got our data needs, our data fixes. Our data needs are data collection, so continuous input stream, and that's the raw data. It's passed on to another data need, which is the need for data ingestion, to prepare data for downstream machine learning applications. That then gets passed to another need, which is data analysis and curation. And it gets passed as indexed data, and it's used to inspect and select the right data. And now that moves on to data fixes. So we've got our data. Now we need to make it available for we need to make it suitable for our needs, so that it's high quality data that can actually, garbage in, garbage out. We got to take out the trash. So the first data fix is that analysis and curation. And once that's completed, it's sent off as selected data. And it's the next fix is data labeling. So we annotate the label, to help train it, so we know, if it's a dog, it's a cat. We gotta do that data labeling. So then the labeled data is set off to data validation, the final data fix, to verify that data is usable for the rest of the pipeline. And now that validated data, now that it's that we've got everything we need and we fixed it up, goes into data preparation, to prepare data for machine learning purposes, split versioning, setting aside from some for the validation, like training it on 90%, validating it against 10%. So now we have a machine learning ready data set. So now we can do model training. So we can use machine learning models to algorithms to create models, which will take a while. Then a model evaluation. So our models go out to the next step, which is model evaluation, compute model KPIs on test set. And then the KPIs, key performance indicators, I think that's what this stands for, goes on to machine learning system validation to validate that overall machine learning system can be deployed. So now we get a machine learning certificate and a validated machine learning system. And then we have machine learning system development. Deploy the machine learning system to production. Now it's online. Now we're assessing the performance, and we're collecting data from the performance, and now we do the whole cycle again to improve it. So ML engineers, data scientists plus data engineers plus software engineers parameterize and monitor, and the cycle continues on and on and on again until you solve all the world's problems, or until you sell whatever product you're trying to feed people down a sales funnel to in order to have them buy. All right, so note this article was updated in March 2023, very old article, very, very old article, and the latest information on ML ops software and service providers. ML ops may sound like the name of a shaggy one-eyed monster. Yeah, that's exactly what I was thinking. But it's actually an acronym that spells success in enterprise AI. A shorthand for machine learning operations, ML Ops is a set of business practices for businesses to run AI successfully. ML Ops is a relatively new field because commercial use of AI is itself fairly new. So we've got ML Ops, the AI lifecycle for IT production. Just read through all that. It's the same image. ML Ops, taking enterprise AI mainstream. The Big Bang of AI sounded in 2012 when a researcher won an image recognition contest using deep learning. The ripples expanded quickly. Today, AI translates web pages and automatically routes customer calls. It's helping hospitals read x-rays, banks calculate credit risks, and retailers stock shelves to optimize sales. In short, machine learning, one part of the broad field of AI, is set to become as mainstream as software applications. That's why the process of running machine learning needs to be as buttoned down as the job of running AI systems. Machine learning layered on DevOps. ML Ops is modeled on the existing discipline of DevOps, the modern practice of efficiently writing, deploying, and running enterprise applications. DevOps got its start a decade ago as a way warring tribes of software developers, the devs, and IT operations teams, the ops, could collaborate. ML Ops adds to the team the data scientists who curate data sets and build AI models that analyze them. It also includes ML engineers who run those data sets through the models in disciplined automated ways. It's a big challenge in raw performance as well as management rigor. Data sets are massive and growing and can change in real time. AI models require careful tracking through cycles of experiments, tuning, and retraining. So, ML Ops needs a powerful AI infrastructure that can scale as companies grow. For this foundation, many companies use the Nvidia DGX platform and Nvidia AI Enterprise, which uses AI tools and frameworks like TauKit, Triton Inference Server, Rapids, and more. So here we have a graphic. ML Ops combine machine learning applications development and AI operations. The source comes from Neil Analytics. So we've got machine learning, a developer, and ops all working together in this big cycle. The machine learn engineers do the data and the model, pass it off to the devs to verify and package it. They pass it off to the ops to release it, configure it, and monitor it. And then it goes back to the devs to plan and create. And then all the way back again in a looping continuous cycle to the machine learning engineer to analyze the data and create a new model. All right, so didn't quite get that in 7 minutes, but moving on. Life cycle tracking for data scientists. With an AI infrastructure in place, an enterprise data center can layer on the following elements of an ML ops software stack: data sources and the data sets created from them, a repository of AI models tagged with their histories and attributes, an automated ML pipeline that manages datasets, models, and experiments through their life cycles, software containers typically based on Kubernetes to simplify running these jobs. It's a heady set of related jobs to weave into one process. Data scientists need the freedom to cut and paste datasets together from external sources and internal data leaks. Yet their work and those datasets need to be carefully labeled and tracked. Likewise, they need to experiment and iterate to craft great models well torqued to the task at hand. So they need flexible sandboxes and rock-solid repositories. And they need ways to work with the ML engineers who run the datasets and models through prototypes, testing, and production. It's a process that requires automation and attention to detail so models can be easily interpreted and reproduced. Today, these capabilities are becoming available as part of cloud computing services. Companies that see machine learning as strategic are creating their own AI centers of excellence using ML ops services or tools from a growing set of vendors. So we have a typical ML pipeline that contains multiple ML environments. So this is Gartner's view of machine learning pipelines. So we have the data pipeline connects to the development, which build, train, and makes a candidate model to pass off to pre-production for integration and validation. Then it's passed off to production. So production deploys it and monitors it, and you'll see this sort of thing happen a lot. This is kind of the big controversy with the CloudStrike thing, where it caused so much blue screen of death. It's like, well, you should have caught that in pre-production, right, before rolling it out to the whole airport, right? So like, this is important, and it's not just in machine learning environments. And then it goes to model management system out there, and we can have a retraining cycle, and we can have a whole cycle in this pipeline. So data science in production at scale. In the early days, companies such as Airbnb, Facebook, Google, Nvidia, and Uber had to build these capabilities themselves. We tried to use open source code as much as possible, but in many cases there was no solution for what we wanted to do at scale, says Nicholas Kumchatsky, a director of AI infrastructure at Nvidia. When I first heard the term ML ops, I realized that's what we're building now, and what I was building before at Twitter, he added. Kumchatsky's team at Nvidia developed Maglev, an ML ops software that hosts Nvidia Drive, our platform for creating and testing autonomous vehicles. As part of its foundation for ML ops, it uses the Nvidia Container Runtime and Apollo, a set of components developed at Nvidia to manage and monitor Kubernetes containers running across huge clusters. So laying the foundation for ML ops at Nvidia. Oops, and I broke my oh, well, that's too bad. I broke something I was holding. Okay. So laying the foundation for ML ops at Nvidia. Kumchatsky's team runs its jobs on Nvidia's internal AI infrastructure based on GPU clusters called DGX pods. Before the jobs start, the infrastructure crew checks whether they are using best practices. First, everything must run in a container. That spares an unbelievable amount of pain later looking for libraries and runtimes and AI application needs, says Michael Houston, whose team builds Nvidia's AI systems, including Selene, a DGX superpod ranked the most powerful industrial computer in the US. Among the team's other checkpoints, jobs must launch containers with an improved mechanism, prove the job can run across multiple GPU nodes, show performance data to identify potential bottlenecks, show profiling data to ensure the software has been debugged. The maturity of DevOps practices used in business today varies widely, according to Edwin Webster. That's a great name. Sounds like a Dungeons and Dragons wizard. A data scientist who started the ML Ops consulting practice for Neil Analytics and wrote an article defining ML Ops. At some companies, data scientists still squirrel away models on their personal laptops. Others turn to big cloud service providers for a soup to nuts service, he said. So this is okay. So this is 40 minutes. So I am assuming that is not a part of this having, taking 7 minutes. They do not expect to have watched this whole thing. I can only assume. I'm probably wrong to assume that, to be honest. All right. So right now we're at almost 6 minutes. So we're wrapping this up. 2 ML Ops success stories. Webster shared success stories from 2 of his clients. One involves a large retailer that used ML Ops capabilities in a public cloud service to create an AI service that reduced waste 8 to 7% with daily forecasts of when to restock shelves with perishable goods. So this is what entrepreneurship is all about, right? Finding that business need and you charge a business, money to have them, they pay you $1 million, you save them $10 million because you figured out a need, and they make money by giving you a lot of money. A budding team of data scientists at the retailer created data sets and built models. The cloud service packed key elements into containers, then ran and managed the AI jobs. Another involves a PC maker that developed software using AI to predict when its laptops would need maintenance, so it could automatically install software updates. Using established MLOps practices and internal specialists, the original equipment manufacturer wrote and tested its AI models on a fleet of 3,000 notebooks. The PC maker now provides the software to its largest customers. Many, but not all, Fortune 100 companies are embracing ML Ops, said Shubhangi Shasith, a senior principal analyst in the following the area at Gartner. It's gaining steam, but it's not mainstream, she said. So lots of good business opportunities here. Hashith co-authored a white paper that lays out 3 steps for getting started in ML Ops. Align stakeholders on the goals, create an organizational structure that defines who owns what, then define responsibilities and roles. Gartner lists a dozen of them. So now we have architecture to operationalize MLDLC. So we can acquire, we can organize and analyze, and we can deliver. So and then here's the roles that do that. Gartner refers to the overall ML Ops process as the machine learning development lifecycle. Yeah. So in my earlier series, we heard about the network development lifecycle. It's the same thing, right? It's just applied to different areas. So the machine learning development lifecycle consists of acquiring, organizing, and analyzing, and delivering. So acquiring, you need the source data. It needs to be structured, semi and unstructured streaming. You can do real-time data coming in, and then you need to integrate the data. Batch data integration, stream ingestion in real time, message broker. Now you have your data engineer that will organize and analyze the data. So it will your data engineer will use a logical data warehouse to store it. Data science and ML tools, data engineering, model training, data and citizen data scientists will organize and analyze. And then they'll send it off to be delivered. And this is where your machine learning architect slash engineer will use a model management system. They'll use model registry, model manifestation, model deployment, and model monitoring. And they'll go back and forth between the actual app developer and the BI developer. And they'll have robust monitoring. They'll have candidate models that they'll do like testing against performance to see which model is better, and they'll work between each other. The app developer will deploy the application. So ML deployment targets, computer vision, language processing, and then perform analytics and BI development. And then the users will be a part of that process because you'll this is part of the analytics, and then it'll go back, right? It'll be in this loop cycle. So the BI developer will determine what sort of inference and monitoring data is relevant, and it'll send it back for retraining. A technical blog from Nvidia provides more details about the job functions and workflows for enterprise ML ops, and a separate blog outlines ML ops best practices. For more details, watch 2 sessions at GTC, free with registration. One lays out the fundamentals in an enterprise ML ops 101. A separate session with experts from Arise AI, AWS, Clear ML, Iguazio, and Nvidia walks through how to develop and scale ML ops workflows. So I can't watch a 3-hour lecture because I only expected this to take 7 minutes, even though it's already taken 20. And there's a lot more to go. And there's another hour-long video at the end. All right. So beware buzzwords. AI, ops, DL ops, data ops, and more. Don't get lost in a forest of buzzwords that have grown up along this avenue. The industry has clearly coalesced its energy around ML ops. Oh man. By contrast, AL ops is a narrower practice of using machine learning to automate IT functions. One part of AI ops is IT operations analytics, or ITOA. Its job is to examine the data AI ops generate to figure out how to improve IT practices. Similarly, some have coined the terms data ops and model ops to refer to the people and processes for creating and managing datasets and AI models, respectively. Those are 2 important pieces of the overall ML ops puzzle. Interestingly, every month, thousands of people search for the meaning of DL ops. They may imagine DL ops are IT operations for deep learning, but the industry uses the term ML ops, not DL ops, because deep learning is a part of a broader field of machine learning. Despite the many queries, you'd be hard-pressed to find anything online about DL ops. And let's do a search for that. Let's go to LinkedIn Jobs and let's search these terms. And now LinkedIn Jobs is weird. Like, it doesn't show me all the jobs. It seems to like only show me jobs that are relevant to me, which sucks. But we got near 2,000 hits for DL ops, for ML ops. So according to this blog post, we should get basically 0 for DL ops. And we got 40,000 hits for DL ops. We got more than 4 times more hits for the one that they said they would have less hits for. So despite the many queries, you'd be hard pressed to find anything online about DL ops. Even though we found 40,000 hits, and we find a blog post and we find lots of information online for DL ops and for ML ops. It looks like we don't find as much information about it. Well, I mean, there's similar hits, But definitely when it comes to the job searching, we did not find the same kind. So here's the first post. So it should say DL Ops on this post. Okay, so I don't see DL Ops listed here. See, this is what I mean. It's like it's so like not straightforward how it actually finds these jobs. It's so annoying. But anyways, way over time. So let's try to finish this out. By contrast, yeah, how's up and coming companies like detailed white papers on MLOps. So MLOps, an expanding software and services smorgasbord. Those who prefer to let someone else handle their MLOps have plenty of options. More than 100 MLOps software and service providers are working with Nvidia. The software providers include Canonical, Charmed, Kubeflow, creates an application layer where models can be moved to production using software certified to run on both single node and multi-node deployments of DGX systems. ClearML, trusted by enterprises worldwide. ClearML provides a unified open source platform for continuous machine learning and is certified to run NVIDIA AI Enterprise. Dataku enables AI and domain experts to work together to build AI into their daily operations and is certified as part of the NVIDIA DGX Ready software program. Domino Data Lab, Domino Cloud, a fully managed MLOps platform as a service, is available for fast and easy data science at scale, certified to run on NVIDIA AI Enterprise. Run AI, Atlas, Run AI's computing platform, functions as a foundational layer, bringing automated resource management capabilities to users' MLOps and AI infrastructure and is certified on NVIDIA AI Enterprise. Weights and biases. WNB's tools may help many ML users build better models faster, debugging and reproducing their models with just a few lines of code, and it is certified with NVIDIA AI Enterprise and integrates with NVIDIA Base Command platform. So cloud service providers have integrated ML ops into NVIDIA accelerated platforms, including any sort of certification here might put you into AOps. I don't see Cisco on that list. So Amazon Web Services, Amazon SageMaker for ML Ops helps developers automate and standardize processes throughout the machine learning lifecycle using NVIDIA accelerated computing. Google Cloud, Vertex AI's end-to-end ML Ops capabilities make it easier to train, orchestrate, deploy, and manage ML at scale using NVIDIA GPUs optimized for a wide variety of AI workloads. Azure, the Azure Machine Learning Cloud Platform, accelerated by NVIDIA, unifies ML model deployment and operations, providing quality assurance through built-in responsible AI tools to help ML professionals develop fair, explainable, and responsible models. So explainable, that's a big thing for AI safety. You want to know what it's doing. It's just like you can think of it like a human, right? Like you want to know if it's going to sabotage things, or at the very least you want to know what it's thinking. Oracle Cloud infrastructure AI services makes it possible for developers to easily add NVIDIA accelerated machine learning to apps without slowing down application development. Alibaba Cloud, accelerated by NVIDIA, the Alibaba Cloud machine learning platform for AI, lets enterprises quickly create and deploy machine learning experiments to achieve business objectives. Kumchatsky of NVIDIA puts tools for creating and managing dataset at the top of his wish list for the community. So there you go. If you're an entrepreneur, fresh out of school or whatever, there you go. Develop a tool for curating and managing a data set. It can be hard to label, merge, or slice data sets or view parts of them, but there is a growing ML ops ecosystem to address this. Nvidia has developed these internally, but I still think it's undervalued in the industry. All right. So let's go to the AI. And then let's say, how can I involve myself? How can I involve myself in open source communities, such as Hugging Face, so that I may be able to develop a valuable product as described in the text above, and sell the product to ML ops teams.
To involve yourself in open source communities and develop a valuable product for ML ops teams, you can follow these steps. 1. Gain a deep understanding of the problem, research existing tools. Familiarize yourself with existing tools for curating and managing datasets. Understand their strengths and limitations.
Yeah.
Study MLOP's practices. Learn about MLOP's practices and the specific challenges faced by teams in dataset management. 2. Participate in open source communities. Join Hugging Face. Create an account on Hugging Face and join their community forums and discussions. Contribute to existing projects to understand workflow and community standards. Contribute to relevant projects. Identify open source projects related to dataset management.
This is the library.
Contribute to their codebase, documentation, or testing efforts. Network. Engage with other contributors. Attend virtual meetups and participate in hackathons or coding sprints organized by these communities. 3. Identify and niche or gap feedback and discussions. Pay attention to community feedback and discussions to identify unmet needs or areas for improvement in dataset management tools. Market research. Conduct market research to validate the demand for specific features or tools within the MLOP's ecosystem. 4. Develop a product. Create a prototype. Develop a prototype of your product addressing the identified gaps. Focus on features like labeling, merging, slicing datasets, and viewing parts of them. Open source your project. Consider open sourcing your project to gain initial traction, feedback, and contributions from the community. 5. Build and engage your user base. Documentation and tutorials. Provide comprehensive documentation and tutorials to make it easy for others to use and contribute to your project. Community engagement. Actively engage with your users and contributors. Address issues, implement feature requests, and encourage collaboration. 6. Monetize your product. Offer enterprise features. Develop premium features or services for enterprise users, such as advanced analytics, integration with existing MLOps tools, or dedicated support. Freemium model. Use a freemium model where basic features are free, but advanced features require subscription. Partnerships. Partner with companies and offer your tool as part of their MLOP solutions. 7. Promote your product. Content marketing. Write blog posts, create video tutorials, and give talks at conferences to promote your product. Social media and forums. Use social media and relevant forums to showcase your product and engage with potential users and customers. Case studies and testimonials. Highlight successful use cases and testimonials from early adopters to build credibility. Resources to get started. Hugging Face community. Hugging Face community. GitHub open source projects. Explore relevant GitHub repositories and start contributing. Kaggle. Participate in Kaggle competitions to understand practical dataset challenges. Nvidia developer program. Join NVIDIA's developer program to stay updated with their tools and resources. Key points to remember: continuous learning. Stay updated with the latest trends and advancements in MLOPs and dataset management. Collaboration. Open source success often depends on strong collaboration and community engagement. User feedback. Regularly seek and incorporate user feedback to refine and improve your product. By immersing yourself in these communities, contributing meaningfully, and addressing real-world challenges, you can develop a valuable product that meets the needs of MLOPs teams and has the potential for commercialization.
So yeah, there you go. That's how you become incredibly wealthy. And how are you going to do this first one? How are you going to gain a deep understanding of the problem? You're going to join a boot camp for $10,000, $100,000. You're going to go back to school for 4 years of your life? No, you're going to go to your local library and you're going to check out one of these books. This book, it looks like it's not available. This book is on hold. A lot of other people are reading this book. So what do? You read a book that is available. So introducing ML ops. Looks like a lot of these books are checked out, which is kind of interesting. Like, it seems like there's a lot of people that are studying this right now. But oh man, that's fascinating. Why are these not available? Oh, it's not in my library's catalog. Okay. Well, how can I filter it out to only see the ones in my catalog? Well, that's too bad that they're not in my catalog. Well, you know how it says notify me and it has this lock there. Oh, well, shoot, I'm kind of making myself look stupid here. So, Oh, you know what? I can unselect this deep search here. So how do I unselect the? How do I turn this off? So include titles, not players. Okay, it cannot be toggled and off. Oh, so this is applied automatically when no results are found at my local at my library. So my library system doesn't have these books, but it shows me the books anyway. So you know what I'm gonna do? I'm gonna be a good guy here. I'm gonna um, request that they get these books, right? If there's an easy way to do that. Yeah, so Libby shares your interest with your libraries. So you know, I'm basically voting for them to get the book. So I think I'm gonna do that. So they'll notify me in the app. Yeah, so I'll try. I'll be do my best to be a good Samaritan, and I'll see if I can get my local library stocked with these books. Kind of sucks that they don't have them already, but it's you know, it's better than doing nothing. Okay, so yeah, those would be probably all you know, all you need in order to really learn this well. Um, you know, there's a bunch of other ones too. So I'll request these as well. Okay, and then you kind of give uh, uh, the library you know an indicator of interest, right? Like the library knows that people at least someone out in the world wants this book, so if they have the option to get it, presumably they will. And you might even, honestly, if you go to your local library and you talk to the librarian, um, you know, it might be super easy for them to get it. They might be able to just do a click and get it. It's just an audiobook. All right, so now I'm going to log into the Austin Public Library System because this Libby was it is part of the Austin Public Library System, but it's not you know, it's a different one, right? So like you get two of them if you are a member at your local library. And then not only that, I have the Wells Branch Public Library as well. So there's actually two separate library systems within like a half an hour drive from me. So I have a library card at both of them. So I don't know my I know my barcode, but I don't know my password. Let me pause it, log in, and I'll be right back. All right, I'm back. So now I have a whole nother thing. So Overdrive is the other version. So I can use Overdrive as well as Libby. So if we go to ebooks like this, and then we search for ML Ops, um, uh, which we can do in the search bar, which is here. Filter your results. So where is the search bar? Oh, it's right here. So now we can search for ML Ops. And there we go. We've got implementing ML Ops in the enterprise, so we can get the physical book too. Like, you know, you don't just have to go with ebooks. Um, so like, you know, the point what I'm trying to make here is that, you know, especially if you're on YouTube, you're like me, you're kind of addicted to YouTube. Um, you know, people are going to tell you can't do this, right? People are going to tell you have to pay for a course, you have to buy their, you know, their coaching, whatever. You know, just open the book, go get it today from the library, and read it. That's all you have to do. Now, it does help to have some sort of credential, a cert to kind of just prove it. But when it comes to learning the material, you don't pay for knowledge. You actively obtain knowledge like you do for exercise. You can't pay someone to make you fit. You can't, you can hire a personal trainer. They can help you, but ultimately you can get down right now and do push-ups, and that's going to get you far more fit than if you pay a personal trainer $10,000. So, yeah. And it's not a perfect analogy because you might be more likely to injure yourself if you don't have a good exercise plan. You might be likely not to recover properly, and not have as good of gains. But the point I'm trying to make is I feel like if you're out there, you probably have more at your disposal than you realize. You have the internet, so just let's search ML Ops just online, right? So there we go, mlops.org. So you can just learn it free online. But you just got so much at your fingertips. I just want to make that point that there really shouldn't be anything holding you back. Google Cloud, it's all out there for free. It says to start for free, right? But just use a book like this and you're good. So it's taken me so far 30 minutes of extra time on top of the 7 minutes it was supposed to take me. So let's try to stay on track. And get this done. So Kamchatsky of Nvidia puts tools for curating and managing datasets at the top of his wish list. It can be hard to label, merge, or slice datasets or view part of them, but there is a growing MLOps ecosystem to address this. Nvidia has developed these internally, but I think it's still undervalued in the industry. So, go to your local library, type in data. Go to your local library online, type in data, and then we're going to say, so specifically what the problem was that curating and managing data sets. So let's type that in. All right, so let's type in data sets. There we go. So data analysis and visualization with pandas, machine learning cookbook. We'll have stuff about data, but this looks like probably what you need. And look at that, it's available. All right, so long-term ML ops needs the equivalent of IDEs, an integrated development of that's brilliant. Integrated software development environments like Microsoft Visual Studio that apps developers depend on. Meanwhile, Kamchatsky and his team craft their own tools to visualize and debug AI models. That's fascinating. The good news is there are plenty of products for getting started in ML ops. A number of industry and open source groups are forming in an effort to help guide ML ops standards and best practices. Nvidia joined the most prominent of these, the AI Infrastructure Alliance, AIIA. Founded in late 2020, it includes more than 60 companies working with a global community of about 30,000 data scientists, engineers, and managers. We will take a seat on the AIIA's board and provide members access to our technologies through NVIDIA Launchpad. So an AIIA working group created this example of a MLOps workflow, so you can see just kind of how crazy it gets. A tool for that would be nice. And I won't read this whole thing. I've already taken 30 minutes of something that was supposed to take 7 minutes. And that's not even the full time I've spent. So NVIDIA Base Command provides software for managing the end-to-end lifecycle of AI development on the DGX platform. NVIDIA also provides a reference architecture for creating GPU clusters called DGX base pods. In the end, each team needs to find the mix of ML products and practices that best fits its use cases. They all share a goal of creating an automated way to run AI smoothly as a daily part of a company's digital life. Finally, Nvidia CEO Jensen Huang shared his views on ML ops and more in this podcast demo. So it's a 4 hour, it's an hour long podcast as part of a 7 minute activity. So I think I'll be skipping that, even if it means not passing this test. So hopefully the test is fair. And when they say, it takes this amount of time, I don't know, man. So next is deep learning frameworks. I feel like, I've spent so much extra time and so deep learning frameworks, this is going to be a long one, again, 5 minutes. So I feel like this is a good stopping point. So what are we at? We're at the hour. That's usually what I'm good for. Beyond that, I kind of can't stay on track as much. So that's it for this video. Stay tuned for deep learning frameworks next.